Hello, G142 students. Here I am with my inability to show me automatically. So I have to go to the camera icon to share. So here I am to help you through Lab 3 about your minerals. You're going to have to, again, check out a mineral rock kit from the LCC campus, and you should be looking in the week 3 module on Moodle with the instructions of how to do that. If you're here in town, if you're close to town, and if you're out of town, meaning Eugene, Springfield area. Okay, so first of all, I'm going to show you the documents that are in the file on Moodle for this lab. So I gotta stop sharing my camera and share screen. First of all, we have a informational document that here's the write-up for the lab. It says lab 1. I'm sorry, this is a PDF and I've changed the number of the lab on this, but it is lab 3. It says lab 2 later in this write-up. So here's the overview of what you're going to do, and then we have a little bit of talking about the different attributes that minerals can have. Okay. So we have, let's see, go down here. We have color. That's one of the things that we consider. Crystal form. If this is how a mineral would form if it was growing freely in an uninhibited environment. So if you've ever seen a geode that has crystals inside, like a thunder egg, then that's that kind of an environment. They're very different than how they might form if they had other minerals growing right next to them at the same time. Cleavage is how a mineral breaks. And cleavage can be, and that's when it breaks on flat planes. You can have one cleavage, perfect cleavage, if the mineral forms flat sheets. You can have two cleavage directions. This particular one, feldspars, have two cleavage that are 90 degrees from each other. And then the third face, they show it smooth here, but it's usually not. It's usually irregular. You can have minerals with three cleavage. There's one here that has three 90-degree from each other cleavage planes. And then the one here, calcite, has three not at 90. They happen to be 60, 120, but they're not at 90, and that's in three directions. You do have some oddball ones that have four, but that's very unusual. Generally, it's two or three or none, because none means that a rock or a mineral has fracture. Okay. So one thing I say up here is that cleavage planes can often appear stair-stepped on the side of a specimen. So they might not look like it's an even one plane, but I'll explain when I talk about luster how you can tell if they are indeed all just parallel planes to each other, and then it would be cleavage, all those tops of the stairs, if you will. So if something doesn't break in cleavage, it breaks with fracture. And here we have a fracture mineral. Quartz has no cleavage, but it often breaks with this smoothly curved surfaces, which we call conchoidal fracture. Other types of fracture are like hackly, like the garnet here. So unlike cleavage surfaces, fracture surfaces reflect light in many different directions because the planes of breakage are not parallel. Okay. Now, luster. Luster is the appearance of light reflected from a fresh, which is unweathered mineral surface. So this is how the surface scatters light. Luster is described in terms of quality and intensity and is generally divided into two basic types, metallic and non-metallic. Now, metallic does not imply shiny or anything about color. I get the idea of, if I think of a freshly minted coin, that to me is metallic luster. Okay. Sometimes you can have submetallic, meaning that it's like kind of shimmery, but it's not flatly like a newly minted coin. And then non-metallic is where that's something where you wouldn't see that made into a shiny metal object for sure, but there's a whole bunch of different kinds of non-metallic. Luster's the big one. For the main one that a lot of minerals are is vitreous, which also means glassy. There's resinous, like if you think about what the tree sap would look like. Greasy, it appears as if it's covered with a thin layer of oil. Silky, it looks like silk cloth. Reminiscent of a fabric, dull and earthy, looks like clay. Pearly, you know, it has like that appearance of pearls. Adamantine is a really brilliant luster, like that of a diamond. Quartz has a non-metallic glassy or vitreous luster. Okay, here's quartz. And you can get sphalerite here, has a non-metallic luster, but it's not as shiny as glassy. It might very well be silky. And then here is metallic luster. Okay, I think this is galena here. No, okay. Oh, take that back. This is gypsum, and this is sphalerite here. My names are off here for some reason. Now, color. This is galena. Color is the most obvious physical characteristic of any mineral specimen, but some things like quartz come in a whole bunch of different colors. Others, yeah, you see one color and that's it, like the gray silver galena. Now remember, this is a doesn't have any kind of a weathering rind on it. So this is a fresh surface for galena. Whereas quartz comes in white, pink, gray, yellow, brown, and even purple, and that's the variety amethyst. Most of you have probably seen specimens of that. At times, it's the color of the mineral upon exposure to oxidation that is diagnostic. Chalcopyrite contains copper, and this often will cause a kind of a peacock shading of here's a fresh specimen on the left and an oxidized specimen on the right here of chalcopyrite. Now, streak is the color of the powdered mineral, and it's not always the same color as a hand specimen. And because of the fact that it's not always the same color, it can be diagnostic for certain kinds of colors. We have and I'm going to show it to you, the little toolkit that you're going to have in the mineral rock kit. There's a streak plate in there, which is a porcelain, a kind of a rough porcelain little plate. And best way you can get streak is to hold that plate down to the table and then really put some elbow grease into it when you scrape that mineral specimen, hopefully an edge of it across the streak plate. And you have a hand lens in your kit as well. It's best to look at it up close if at all possible. If you think about it, a light colored specimen may very well yield a white streak, and the streak plates are white. So you got to make sure you have a clean streak plate with no dust on it. And then once you've scraped your specimen over it, you can use your fingertip to see if there's actually any powder left. And I'll be showing you how to do that as I'm going through the different minerals. Now, hardness describes a mineral's ability to resist scratching or abrasion. Hardness can be determined by trying to scratch a mineral of unknown hardness with things of different hardnesses. Okay, so I have on here, these are a little bit generous with the numbers here. Fingernails. I don't think that these are quite right, sorry to say. I'm going to put on the board behind me I'll post it on Moodle what the scale should be, because I don't particularly like this. Streak plate is right, but at 6 to 6.5. Glass plate though is like 5. Steel nail is probably 4.5 to 4. Copper penny is 3, and a fingernail. That's an awfully hard fingernail. If you've got a 2.5 fingernail, it's probably your thumbnail, and you've got really hard nails. Most nails are down around 2 to 1.5. And I would suggest you use your thumbnail, because that is the hardest one on most people's hands anyway. Okay, and the streak, we're going to use these objects here in our toolkit that comes with your kit in order to investigate how hard the minerals are. We're going to document that. Okay, specific gravity, that is the volume of a mineral, like some particular volume, like 1 cubic centimeter, compared to what the weight of water would be for that volume. There's no way, I'm not going to make you do that. You probably don't have the scales to be able to do that at home. So what we're going to do is we don't specifically ask you to put it down on the chart you're going to fill out, but you might just weigh in 2 hands, 1 mineral compared to another. And if one is really heavy, then it's probably got, it has to have a higher specific gravity than the one that is got less weight to it. Metallic minerals especially have a tendency to have a higher specific gravity. Now, some specimens that are made out of calcium carbonate, like calcite, will actually effervesce when treated with dilute hydrochloric acid. And if you powder, calcite's relatively soft. If you powder the mineral specimen a little bit so that it's a little bit of powder, and you could use your household lemon juice or vinegar, and as long as it's in a powdered state, if it is indeed something made out of calcium carbonate, it will cause some effervescence, and you can see that here in this picture. Now, magnetism, some minerals such as magnetite exhibit magnetism. I don't know what happened to the pictures here. This magnetite specimen got kind of cut off. It's been oxidized a little bit. You can see the orange on it. Some of the specimens that we have in our mineral kits here at the college, some of them have some of that orange oxidation on it. Some of them don't. So you very easily could have a black specimen if that is one of the things that we have in our kit. Another dark one is graphite, which actually is so soft that you just pick the specimen up and it'll leave behind gray marks on your fingers. And graphite is what they put in pencils, mechanical pencils and regular pencils too, for that matter. And so it's very easily torn apart by scraping it across paper. Some minerals on their cleavage planes have very thin lines called striations, like this plagioclase feldspar that I have showing here. And some types of plagioclase feldspar, because there are different varieties of it, this one, labradorite, also exhibits, maybe not as bright as the color picture I've got here, but some of them have this iridescent optical effect that when you move the specimen around, the light penetrating to the inside of the mineral is very brightly shimmering of different peacock type colors, blue and to peacock green. Now, there's a little bit about importance of economic minerals here that I think some of the question worksheet might ask you about. And now, how do you go about identifying? Okay. So the first thing you should do is, when you look at each of the minerals, is to determine, is it metallic, submetallic, or non-metallic? Okay. And then list as many of the physical properties of each metallic mineral and all the rest of them that you can observe with your mineral testing kit and your senses. And you record all these observations in the Excel file, which I'll show you next. And that Excel file is something you're going to have to upload into Moodle. Now, if you have the ability to print that Excel file out into a hard copy, then you can fill out that chart by hand. If you're going to be doing it on your computer, if you can, my understanding is, as a student at Lane, you can get Microsoft Office uploaded into your computer, as long as it's got the energy or the memory to be able to do it. You can do that for free if you talk to the people at the sheds, a student help desk that is there in the library. And I've put their email address and also their website address and also their phone number on the explanation for this folder if you want to get in contact with them. You can then have Excel on your computer. If you're going to use a Google Doc version of that chart, that's fine. But since you have to upload that chart, you have to have it be either Excel or a PDF file before you can upload it into Moodle. I can't open anything else. And that's the only way I'm going to be able to look to see if you did indeed complete the chart as you're supposed to, okay? So I'm going to also show you these mineral charts here that I'm referring to. When you've got all of your attributes of your minerals written down on your chart, then we have these 5 mineral charts that are there in the folder for this lab, and I'll show them to you in just a minute, that separate out the minerals into basically 5 categories, because one's for the metallic and submetallic, and then 4 charts which separate minerals with non-metallic luster into 4 categories. Those minerals with cleavage and hardness greater or equal to a glass plate, minerals with cleavage but a hardness less than a glass plate, minerals with fracture but hardness greater, minerals with fracture with hardness less than. So here's a few hints to provide I've provided from mineral specimen A to get you started. And again, you don't have to watch the rest of this video. You can try it on your own, but I'll tell you right now, it's probably a lot easier just to at least have me take you through a few of the specimens so you can get an idea about how to look at them, how to test them for hardness, etc., and how to use those 5 charts that I've just delineated. So stop share this. Oops, I should have stayed in there. Okay, so here's the mineral identification charts that I was just discussing. So here's chart A, minerals with metallic and submetallic luster. Okay, so first of all, it says, what's a luster? And then it says, what color is the streak in general? And then you go to that section and you see if that, if the hardness, the color of the streak, etc., match what you got recorded for that specimen. Section B, non-metallic minerals with cleavage or parting. So here it's cleavage, and then you go, is it softer than glass? Then you got to go to the next chart. If it's about the same hardness as glass, was right around 5 to 6, then you would use this section. If it's harder than glass, meaning it's greater than, it's like 6 to 7, then you use this section. Okay, and you start at the bottom and kind of read your way up. So here's the cleavage softer than glass. Starting down here, it's hardnesses of 2 all the way up to hardnesses of 4. Here's the non-metallic minerals with apparent fracture that are harder than glass. So it starts about 6.5 to 7, it works its way up. And then the last chart is the ones that are softer than glass. So we start out with things with a hardness of 1 and work all the way up to things with a hardness of 5. Okay, so that's those mineral identification. Oh, I did not have that shared. Ugh. Okay, what I'll do is I will go back to Zoom. I'll share it real quick. It's irritating. Okay, here's E, D, C, B, and A, which is the one for metallic cluster. All right, so you're going to want to have them open on your computer when you're doing the lab so that you can refer to it. And I'll show you but I'll be going, back and forth between specimens and lab, these pages for this. You might want to have it so you can look for it here yourself, okay? All right, so what do we got next? Share screen. So here's the chart that you're going to be filling out. Why is that not? Share screen. I don't know why. Oh, you are screen sharing. All right. For some reason, it's not showing big on my. So it says I'm showing you the chart. So you can see how we only have specimens A through J. And then you're going to document the color, the luster, the streak color, if any. It's hardness that you figured out from using the hardness tools in the toolkit. If it has cleavage, how many planes and at what angles are they? Or if it doesn't have cleavage, it has fracture. So do you think it's conchoidal or irregular? Are there any special properties or any? Does it have a greasy feel? Does it effervesce if you try it with lemon juice? Is it extremely heavy? So on and so forth. And then what you can determine from the mineral name by using those 5 charts that I just showed you. All right. And then the last thing if you've got that chart filled out, then I'm gonna go real quick through, whoops, share. I'm gonna go real quick through the question sheet that you are gonna go in and put the answers that you've decided on this sheet from comparing it to your mineral chart and put them in a quiz format. And then that's 1 through 25. And then 26 through 30, okay, you're going to use those mineral charts in the Lab 3 folder. And I've given you a picture and a description of a mineral. And then you're going to tell me which mineral is that, okay? So you just use those mineral charts, just like you're going to for the specimens that we're going to use to fill up this chart. Okay, and then I'll go, once we're done with the chart, then I'll probably cut off and then do a separate video going through the first 25 questions on this question worksheet. Okay. So now I've got to power up my system so that I can change to the document camera. Because I'm going to be showing you specimens and then having that chart that we're going to fill out there. And also those 5 mineral charts that we determine what our specimens are. Okay. Okay, so let's see. Share screen. Is it sharing it? No, it is not. Why is it not sharing? Well, that's going to be a problem. Ooey. Okay, so PC. All right. I guess I'm going to have to do this the hard way by sharing that screen. But then I can then like if I change this, oh, is that gonna? I'm gonna try this and see if it works. That changes that, doesn't it? The screen for me when I'm looking at it is tiny. Okay, so where it's big, I got 2 screens here. The one I'm looking at with the camera on it, and then the one that I'm going to be typing on, okay? So how am I going to show you specimens? The rock kit that you're going to go check out looks like this. Okay. Is that backwards? Probably. Inside of the rock kit, there's 3 rows plus the 4th front row. The front row holds the toolkit. And the toolkit, and you might want to write these down for the hardnesses. The toolkit consists of a what we call a hand lens. Okay, and this enables you to look at the mineral really close. And don't hold it out like this with the mineral specimen in front of you. Don't hold it out, way in front of your face like this. Hold it so that you're up close and personal with the mineral. Okay. Up close and personal. I have the light off here because I thought that I was going to be using the dock cam, so I don't have very much lighting here, but be sure that you have some pretty good lighting when you do this lab and the other labs with the rock specimens that are also in this kit. Okay, besides the hand lens, we've got in the toolkit, we have the things that you're going to use to determine hardness and streak. Okay, now remember, your thumbnail is 1.5 to 2.5. You have an idea about how hard your nails are. And if you have fake nails, that's going to be a hard one because they're not the same. Okay. Penny, notice how shiny this one is? We tried to put shiny ones in. If we didn't, remember that if you have a dull penny, one that's darker than this, it's because it's got a weathering rind. And the weathering rind is not going to be as hard as the actual metal shininess. So this is a hardness of 3. Okay. Now, there's 2 nails in here. I'm not quite sure why. One's really tiny and one's big. I have to figure, okay. This is probably 4.5. If you got one that looks like this, it's probably a 4.5. If you got one that's smaller, especially if you got a little one like this, then it's probably closer to 4. They don't make all nails out of the same type of metal. Well, at least the same strength of metal. Okay. You also have the next hardest thing, which is the glass plate. And we tried to make sure that they're all relatively unscratched. These kits have been used by more than a couple of terms worth of students before you. And we go back through and make sure all the specimens are good and that hopefully that the glass plate's not too badly scratched. That's a 5. And then your streak plate, okay, is 6 to 6.5. Okay, so those are the specimens or the things that you have to test your specimens with for hardness. And then you should have a magnet. That's the last thing that you should have in your kit. Okay. So, and I might be remaking this video if I could figure out how to get the document camera to show on the. Okay. So, I'm going to put the glasses on here. The first specimen is specimen A. Some of you may have a specimen that has a little bit more color to it than this, maybe a darker pink, maybe a salmon color. So, oh, I gotta go back to my camera to show you that. Okay, so now you're seeing me, right? Here's specimen A. So some of the specimens, like I said, are going to be a darker color than this. We tried to make them all be pink of some shade because that's important for the group that we wanted you to figure out this was. Okay, so the first thing that we put down then on our chart, and let me write it in here, is pink. Now, if yours is more salmon flesh colored, then that's probably what you would want to put, okay? Now, the next thing we have on our chart, and I'll show you the chart after I've filled in a few of these blanks, is the luster. Now, does this look metallic to you? No, it's non-metallic. And notice when I move it like this, how you get that blink of light, okay? That is glassy luster. And it is reflecting off of, on this specimen, a relatively flat surface. You know, there's one little stair step right here. I can feel it. There's an edge there. But other than that, you know, that stair step is equal. It's parallel to the one, you know, this one is just a millimeter below this one. Okay. So I can tell by that already that it has at least one plane of cleavage. But that blinking of the light, that's that glassy luster. Okay. So we're going to put on our chart under luster for specimen A, glassy. Yeah. Keep my fingers on the right. Okay. Streak. Here's my streak plate. Here's my specimen. I'm going to take an edge, like this edge right here. I'm going to put this streak plate straight down on the table, and I'm going to really give it a go. Okay, so make sure my streak plate doesn't have any extra powder on it of any kind. The last people who used it, and really dig in. I don't know if you could hear me, that scritchy sound, okay? That was from the specimen. Okay, now, when I look at the streak plate, it just looks white. It doesn't look like it has anything on it. But when I put my finger against it, Now, do you see that little bit of powder? So it has a streak and it's white, but it was hard to get. I mean, I really worked at it and it gave me almost nothing. So if you remember the streak plate is 6 to 6.5, that means that this hardness is really close to 6. Now we could, let's say, substantiate that a little bit better by using the glass plate and seeing if it's really close to 6, 5.5 to 6, then it's going to scratch this glass plate that is a hardness of 5. So again, glass plate against the table, scratch a corner against it, and sure enough, I got, I don't know if you could see that scratch right there. There's a scratch right there that I made just now. So for hardness, I'm going to have 5.5 to 6. And you can, I like to have these centered that way. Okay, so let me stop me and go to that file so you can see what I've added to it. Okay. All right. Well, now what about cleavage? Okay, let me go back to where you can see the specimen. I said there's one here, but there's also another set of stair steps over on this side. Okay, so can you see how this one's up here and then this one's down here? Now, if I show that one to you, see the blink of light? That's another set of cleavage. So the angle between the two would be this angle. This is one of my cleavage planes, and this is another one. Now, the other side doesn't look nice and square like that, does it? Well, sometimes these minerals don't break with perfect cleavage, but you got to think about when you have cleavage, it's usually, you know, two sides to it, right? Two parallel flat surfaces. So one, and then the other one is going this direction. Okay. And they come together at 90 degrees. Okay, so we're going to put 2 at 90 degrees. Now, special properties, if any? This one, not really. Not really. It doesn't really have that anything particular that makes it stand out, except if your specimen is really deeply salmon colored, that might be one you'd want to put down there. Okay. So now let me take, stop share this and go into the mineral charts again. And what do we have? We have non-metallic luster. We have hardness that is 5.5 to 6. So that's greater than glass, right? So we're going to scroll down here to this B, which is minerals with cleavage, parting that's harder than glass. Okay. Let's see. About as hard as glass. Do we have anything that's pink down here? Hackley to white, colorless to gray, blue gray to green, that didn't work. Medium to dark green, that didn't work. Greenish dark gray, that doesn't work. Dark green to black. Okay, none of those colors work. So now we come up here, and the first one we have is hardness of 6, cleavage 2, good planes at 9, about 90. That works. White to gray, greenish or bluish gray. That doesn't work because it doesn't say anything about pink there. So let's go up to the next one. Hardness of 6, cleavage good, 2 planes at 90, white, cream, gray, salmon to dark pink, luster's vitreous, which means glassy, A pink color often distinguishes K-rich feldspars, which is potassium-rich feldspars. Okay, which, there we go. So over here on our chart for our mineral name, we're going to put down alkali feldspar. Okay, so let me stop share on the keys and go back to our Excel chart. Okay. Let's see. All right. So one down. Going on to B. Now, I don't know if you got a specimen like this or which one of these you got a specimen of. Oh, I don't think I'm with you. Okay, B. My kit is my teaching kit, so it always stays here, and I do these videos with it when I need to. This is the specimen I had in my kit. This is how this mineral forms when it's given free open space to slowly form over thousands of years, perhaps. Okay, so you can see what it looks like here. This is how that same mineral, when it's in a big, huge mass, breaks. Okay, so I'm not sure which specimen type you got in your, that's one of the reasons I do this video, is because it breaks differently than it forms, true? And there's no flat surfaces. In fact, this is a round surface because this particular specimen probably came from a round cobble that had been weathered and eroded so that it was nice and round. And then somebody came along with a rock hammer and busted it open. And that's how it broke, was these surfaces. Okay. So what do we have to do? What color? Well, this one's clear, right? Whereas this one's white. And depending on the specimen that we stuck in your kit, I think we probably tried to go this direction or this most of the time. This could be light gray, maybe even pink, a little bit pink, but less likely to put them into our kits. Okay, so on our chart, I'll show you in a little bit, I put white. I'll put white. What about Celester? Well, this is a weathered surface, so that wouldn't work. But if you look at the other surfaces, you know, do they blink any light at us? And this is a tough one. You see a little bit right here? Now, it's not near as shiny as the flat plane on our last mineral, right? But it does blink light back at you, okay? Now, if you're thinking about this one, there's no doubt, right? Shiny blink of light back at you. So again, non-metallic with glassy luster. Okay. Now, streak. So clean off your streak plate, right? Take your specimen, take one edge of it, and scratch it across there. I got a little teeny bit of powder, but I also, well, but the problem is that I think I may have, the powder might have been the streak plate. Okay, because the second time I did it, I didn't get a powder. What that means is that this is harder than 6.5. Now, we don't have a specimen in our toolkit that we sent you that is harder than the streak plate. Okay, so all you can really say on your, you know, if it's harder than this, you just know it's like let's say the next half increment up, that it's got to be that or more, right? So it's got to be greater than 6.5. Let's put it that way. Where's my little greater than symbol? Greater than 6.5. No, wait. None in the way of a streak, and then hardness greater than 6.5. Okay, and let me clean this up and then I'll show it to you. Okay, so stop share here, go over and share that screen with you. Okay, it was white in color. Glassy luster. I don't know why this is not cooperating. Didn't have a streak. Harder than 6.5. To have no streak or a very, very little one, got to be harder than 6.5. And then does it have cleavage? There's no flat planes on this. It broke. And in fact, this one is slightly curved. This break has got a very slight curvature to it. This break has got a pretty good sized curvature to it. I mean, my finger fits in the hole there kind of. This has got a little bit of curvature to it right here. So because it has some places where there's a curve, we're going to call this conchoidal fracture. Okay. Special properties? Well, I've shown it to you. You might not have one in your kit, but I've shown it to you where it forms elongate prisms. That's its crystal habit. Okay, so we could say here, crystal habit. Crystal habit. Elongate prisms. Okay. Wrap text. Center. So let me go back so you can see what I put in there. Okay. So what is that? Well, let's go back to our charts. Okay. What we have is a non-metallic mineral that is harder than glass, but has fracture. So we want to go to section D. So down here at the bottom, hardness of 6.5 to 7, conchoidal fracture may appear irregular due to small grain size. Well, I don't know about that. Light to dark olive to yellow green, that doesn't work. So the next one up, hardness of 7, fracture conchoidal, color varies widely, colorless to smoky in common rocks. That's D means the density or the specific gravity, but we really don't know. We can't really test that. Luster is vitreous, which means glassy. Microcrystalline varieties of this get a waxy luster, like chert. Hexagonal crystals show striations perpendicular to prisms. Is that crystal hexagonal? 1, 2, 3, 4. It does indeed have 6 sides. Okay, well, quartz may be colors and have many varieties of color. That is quartz. So for our mineral name here on our chart, we're going to put quartz. And let me go back and show that to. Okay. All right, moving right along. Ooh. Now, some of you might have a bigger chunk of this than I do. Okay, so let me get back here to the camera. This is what I got in my kit for C. All right, well, first of all, what color is it? It's kind of a brownish black, right? I mean, when it's this thin, you can actually, the light will come through and you can see that it's a really dark brown. You might have a slightly thicker specimen and maybe the light's not transmitting through it, but it is a brownish black. So for our color on our chart, that's what we're going to put. Sorry, I wish I was a better typist under pressure. Okay. Luster. Well, does my specimen gather light and shine it back at you? Oh, yeah. In fact, that particular kind of non-metallic luster for this particular specimen, I mean, this mineral, they call that splendant. Or is it int? I don't know why, I think it's A-N-T. Okay. But it's not quite as sharp of a blink at, see how it kind of goes across the specimen? It doesn't all happen at once. So it's not really truly glassy, although it, it reflects light really well. So what about streak? Well, the problem with this is that it's so thin, this particular specimen is so thin, and it's flexible. In fact, that might be a special, one of the special properties it would have, right? So it's really hard to say streak. But think about it, it is a dark mineral, so I would think that it would have a dark streak. Not that 100% dark minerals have dark streak with question mark. Okay. So maybe we want to put dark question mark. Now, if you have a thick enough specimen where you've got a whole bunch of these sheets together and you've got a thicker specimen of a whole bunch of sheets, then you could probably scrape the cut edge along the streak plate and actually get something. But a lot of times it's more likely just to break off little tiny bits of the sheet itself, not powder it. So it's tough to get a streak on that particular type of mineral. So dark question mark on that streak. All right, now hardness. Well, if we can't get a streak, I mean, even me, if I were to scrape this along here, I might be able to break up. I don't think that this is not gonna cut glass, right? Even if you had a specimen that was thicker, that had more sheets involved, it's not gonna cut glass. Okay, so the next thing you would do is, can you crease this? Can you break the surface of this with the tip of your nail? Okay, so I'm gonna try to do that. All right, and this is what I got. So that, see? So I broke the surface of this with the tip of my nail. And that was with the hard nail, but even if I draw the soft nail, yeah, I could do that, okay? So that's 4.5. What about the penny? Can I do that same kind of scoring of the sheet with a penny? And yes, I can. That's that one right there. Okay, so it's not as hard as a penny. What about your fingernail? Yeah, my thumbnails are pretty hard, and looks like I might have been able to get a little teeny bit of damage, but not like the other tools. Okay, so it's less than 3, but maybe 2.5. Okay, so let's say 2 to 2.5 for the hardness. Okay, I'm going to show you what I got on the chart so far for this one. Sorry, I can't use the document camera. Thought for sure it was going to work. Okay, brownish black, splendant, dark question mark for the streak, because you should have been able to get one with this hardness. What about cleavage or fracture? Well, oops. If you use the finger and the thumb on a flat plane, that is 1. Even this specimen, as thin as it is probably a good 3, 4, 5, 10 sheets if I could get them pried apart. See how this was coming off here. Okay, so this is not cleavage, even though it's been cut. It's actually been cut with a rock saw in these like kind of rectangular shapes, okay? So this is one perfect cleavage. That's the cleavage that this specimen has, is one perfect. And then what about a special property? Well, what did I say these sheets were? If you had a few of them together like this, flexible sheets. Okay. So let's go back and look at the mineral ID charts and figure out what this is. So now we have something that has cleavage, but it's softer than glass, right? So we want to go back up to section C. And let's see, start at the bottom. Hardness of 2, can scratch with a fingernail, cleavage of 1 perfect in sheets, and 2 more irregular cleavages. Oh, well, that doesn't fit. Colorless to white for color, that doesn't work. So it's not that. Hardness of 2, cleavage of 3, perfect at 90, that doesn't work. Hardness of 2, 2.5, cleavage of 1, perfect, but flakes are small compared to micas. Medium to dark green, that doesn't work. Hardness 2.5, cleavage 3, perfect at 90, that doesn't work. Hardness 2.5, 2 to 2.5, cleavage 1, perfectly planar, that works, but the color doesn't work. Colorless to white to light greenish brown, and the streak is white. May break apart when testing. Resinous to vitreous to pearly. A lot of that works, except that this is definitely dark brown, not greenish brown. So let's see if the next one's good. Hardness 2.5 to 3. That's a little bit harder than the other. You can mark it with your fingernail by creasing sheets rather than scratching. So maybe I was creasing it instead of actually scratching it. Cleavage 1, perfectly planar, dark reddish brown to black. Aha. Streak light brown. May break apart when testing. Luster, splendent to vitreous. Okay, so there's that, and it is splendent. Never remember how to spell that. Elastic, flexible, and transparent in thin sheets. Transparent because light will come through it. So what do we have here? Biotite. So let's go back over to our chart. Whoops. Flexible sheets. Next one. You don't have to put yours in the center like this if you're doing this. It's just, I like to have them that way. Okay. Now, I did not determine the streak. So yeah, the chart tells me it's supposed to be light brown, but since I couldn't determine it, I can't change that to light brown. Now, if you have enough of a big enough chunk of this that you could, then yeah, sure, you could put it there. But I don't think that's something that I ask you on the actual specimen question sheet. So what you put there should be true to what you actually collected in the way of information. All right, so now go back to the camera. Sorry, you have to look at me so much instead of just looking at specimens. All right, here's my next specimen. Okay, it might look cubic, but it's not, because the angles are not, they're not 90 degrees like this one here is a little bit this bigger, this one's smaller. All right, so color, mine's white. Some of you might have one that's got a little bit of discoloration and maybe might look yellow. Okay, so you should put down the color that you had. Luster. Hopefully, you'll get a specimen that at least has one of these flat faces that'll shine at you. There it goes. Okay. Blinking light, and it's kind of sharp, that's glassy. Now, you could, if you felt appropriately, you could put maybe waxy or I don't know about pearly or silky. If it doesn't, if you don't feel as bright enough, shiny, but you know, most specimens should be glassy. Okay. Streak color, if any. Well, it's a light colored specimen, so the implication is it's going to have a light colored streak, but you want to make sure you don't have any other powder on there right before you do it. And then elbow grease. So I did it. Can you see the streak on there? No, but if I do my finger, yes. Can I get it up here where you can see it? Okay, let me do it again. So the streak is most definitely white. Hardness. I didn't really even have to push that hard to get that streak. Okay, so the next one down is what, our nail? Okay, so hold the specimen down and then scratch it. Oh yeah. Big nail did it. Little nail did it. Where's the next one? Our penny? Not quite as easy, but it did it. Okay, so the penny maybe is approaching the low end of what can actually do some damage to it. So we're going to put down here that its hardness is 3. Okay, so let me go over there to the chart so you can see what I put on there. White color, glassy luster, white streak, hardness of 3. Okay, so now cleavage. Hopefully, well, your specimens, some of your specimens might have a little bit of stair stepping on them, so they might not be perfect, but the one I've got, perfect. There's one. There's a little stair stepping on this side here. There's 2. Okay, so 1, 2, 3. But if you look at the end of this, that's not 90-degree angles. This is bigger than 90, and this is less than 90. Okay. So for cleavage, 3, not at 90 degrees. And if you felt confident enough about it, you know, you could put 61 at 60, 120, but really, you know, that would, you should be getting like the calipers out or the protractor or whatever and actually measuring that angle. And we're not asking you to do that. So technically, all you can say is 3 not at 90 because they're not, you know, they're not perpendicular to each other. Okay. Any other properties? Well, if we were to look this up now on our mineral charts, okay, before we might find something that we could test. So let's go do that. This is a visible cleavage softened in glass. Okay. So let's see. Hardness of 2, hardness of 2, 2.5, 2 to 2.5, 2.5, 2.5, 2.5 to 3. That was biotite. So it's okay. We're going on up. Hardness of 3, cleavage 3, not at 90. Perfect rhombohedral. Aha. You know what a rhombohedral shape is, like a diamond, right? Colors vary. Colorless to white to yellow to pink. Streak is white. Luster is vitreous with glassy. Ooh, if it's calcite, it strongly effervesces with a dilute hydrochloric acid. Okay. I wonder if this camera is going to be able to capture that, if it's going to. So I got myself some hydrochloric acid. And like I said, if you wanted to test this specimen, if you have some lemon juice or some vinegar in your house, you don't need very much, just a little bit, but you might need to powder your specimen a little bit, like with your, the edge of your nail tip or something like that. But I'm going to put a drip of this on here and see if I can get it so that you can actually see it effervesce. I can't get it too close or you're not going to be able to see it. You see the bubbles? Afraid I can't get it to focus in close enough. There's a huge bubble on this. I'm dripping this acid on my keyboard. That's not good. Okay, it bubbled. It effervesced. So this is indeed calcite. Okay, so we can put on our form then, our chart. Effervesces, I don't know if I'm spelling that right. Oh, I'm going to go the easy way. Bubbles with dilute acid. And then over here, it's calcite. Ooh. Okay, that's specimen D. Moving on. Specimen E. Most of your specimens, we tried to get, I mean, this particular mineral comes in a variety of forms. We tried to get most of them to look somewhat like this. This one's a little bit clear. You can see a little bit of light coming through it. Yours might not be quite so clear. More of a white, kind of like that calcite was, but okay. So mine's clear to white, depending on where on the specimen I'm looking at it. What about luster? I'm getting a pretty good blink of light, right? So it does have a little bit of a kind of a subtle waxiness to it though. So let's say, and depending on what your specimen is, waxy to waxy is what I'm going to put for my specimen. If I can spell it. Streak. All right, again, clean off make sure you don't have any loose powder on your streak plate. And scrape your specimen along there. Oh my goodness, yes. I got a whole bunch. Okay, and it's white, right? So we can put the color down as white. And then hardness. Well, it's definitely less than 6.5. Can it scratch glass? Nope. I tried. Nothing. Can we do damage to it with like maybe the softer of the nails if you've got it, oh yeah, my little nail does damage, so it's got to be less than 4. What about the penny? Can the penny do damage? Oh yeah. Yeah, see, I got little white chunks left on my penny. So it's softer than 3. Can my thumbnail do it any damage? Yes, actually it can. Can you see the powder underneath my thumbnail? So it's got to be probably 2 because my thumbnail's pretty hard. So let's put down here 2 for hardness. Enter all that. Let's go back over and show you what I got on there so far. So for, okay. Clear to white, glassy to waxy, white. Now, if yours is clear, just say clear. If you feel like yours has a really, really brilliant flash of light when you move that, then, put glassy and don't put waxy. What about cleavage? Well, if you look at the specimen, my specimen, it looks like it has flat planes. Okay. So, right? Does it have more than one though, is the thing. To be honest, I can't remember. The problem is that they're going to have a lot of description on this chart, these identification keys, because this has a variety of different forms that it can take. But it does, let's say it has cleavage and it's softer than glass. Okay. This particular one, I think, is the one they used for the charts. So let's say one perfect. This looks curved, I don't know, but it's just very, very tiny, tiny stair steps. And this one is most definitely stair stepped. You can see the edges here, right, that it's going up. So one perfect for cleavage on this. Special properties, if any? Well, if we'd have had this first, because it has one perfect, and if you weren't sure what it was, you could have tried the acid on this, but it wouldn't have done anything. So really, this particular mineral, although it's pretty important industrially, it doesn't really have a special property that you could put down there. Okay, so now we want to go, let's go back to our charts. And minerals with visible cleavages that are softer than glass. So let's start at the bottom again. Hardness of 2, can scratch it with a fingernail. That works. Cleavage 1 perfect. You know, it's in sheets. That works for this specimen. It may, and maybe 2 more irregular cleavages. Like I said, you know, it looks almost like it curves on one side, but streak is white. Yeah, that works. Vitreous to pearly. Aha. I said waxy. Maybe pearly was a better name for the fact that it didn't look really, really glassy. It's flexible when it's in thin sheets, can shave with a knife, which I don't have a knife, so I'm not going to try that. Transparent to translucent. Well, this particular specimen that I have is that, because you can see light coming through it, even as thick as it is at 1/4 of an inch. So I could add that as a special property, I guess, since I can see it once I've seen it. And that is gypsum, the variety called selenite. Is the one that we have here. Like I said, there's a bunch of different varieties. Okay, so let's go over to that chart again. All right. We're halfway done. How long is this on? We're already here way too long. Up to you if you want to stick with me for the rest of them. You can try it on your own if you'd like, and then maybe just spot check with me. It's totally up to you, what you want to do, okay? So back to looking at the specimen itself. I've seen better specimens of this. Hopefully you've got one that's a little bit better than the one I've got. Okay, well, clear. Some of them, if they are ones that have been around a long time in our mineral drawers here on campus, they might get a little bit of a opaque outer coating to them because of the fact of people handling them, you know, like the oils on their hands. So this is F. We're going to say clear. Spell it. Luster. Does it have? It does indeed have light blinking, but it's not super, super bright. Okay. So this is another one of those where it's not pearly, like maybe that selenite was, but this is another one where we maybe say to glassy to waxy because it's not a real super bright shine on all the flat surfaces that it has. Streak, again, clean the plate off. Oh yeah, easily got it broken off. In fact, some of them are big, not just powder, it's chunks. Okay, well, let's go all the way down to let's go all the way to the other end, the penny. Can you do damage to it with the penny? Yep. I could score it with the penny. You can see that scrape right there. Okay, which means that it's less than 3, but can I do it with my thumb? I can even do it with my thumb. So we're gonna be around 2 again for hardness, and the streak was white. Okay. Cleavage. All right. Well, there's some stair stepping going on this specimen, but I do have, there's one. Okay. This is stair stepping on this side here, but this is a bit flat here. So that's 2. And then here's 3. And they come together at a perfect 90-degree angle. That one's 90, that one's 90. That one's 90 between my fingers. Okay. So 3 at 90 degrees. Transparent? All right, so let's go back to our charts. Well, let me show you what I've got written down for this one first. Okay, I got clear, glassy, waxy, white, hardness of 2, 3 at 90 degrees for cleavage, transparent. So now let's go to our charts. We're still on this cleavage and softer than glass. We know it's not gypsum because we just saw gypsum, right? Let's see, hardness of 2, cleavage 3, perfect at 90, colorless to white to pale blue, streak is white, waxy to vitreous, which is glassy, bitter, salty taste. Well, no, do not put your tongue on this thing. I can tell you though that it is not bitter tasting. And if you, it says, notice how it says dissolves in water and on fingers. Your fingers are gonna have to be pretty sweaty to do that. So it's not Sylvite. So we go up here and this is the one that was medium to dark green chloride. So that's not it. How about one hardness of 2.5, cleavage 3, perfect at 90, colorless to white, streak is white, waxy to vitreous, that all works, salty taste, transparent, dissolves in water. Okay, this is it. It's not bitter, it's salty. So that's halite. And in rock forming quantities, it's called rock salt. Okay. Back to the chart. Now we're going to go into the darker couple of them, more of them are darker on this one. All right, so G. Well, this is the one where if it has a little bit of a weathering rind on it, might be a little orange or just red. My specimen is black. There's no color but black. Okay. Now here's where it gets tough. There's no shiny surface on this. Oh, except for right there. Get a little bit to it. But it's hard to show with this camera what you might be seeing if you look at it in good light with your hand lens at your house. That there are places on here that it does have a little bit of a shimmer. But notice in this one, it's not necessarily all of it. In fact, it almost looks blue with this camera. I don't think it's really that way here. But there's no like whole one flat plane giving you light at the same time. Okay, so there's no cleavage here. This, believe it or not, is what we would call submetallic luster. Okay. All right, streak. Well, looking at it, it's going to be dark, you would think, right? But take that off there anyway. Make sure there's no powder on it. Do you get a streak? Now, I got a real thin line. So in order to determine exactly what color of dark that is, I should probably look at it with my hand lens so I can see it up close better. Because sometimes when you get a dark streak from minerals, it can be have a little bit of a brown tint or a little bit of a green tint. So it's best to look a little bit closer and see. And this one just looks gray black. Fingers on the right keys, woman. Okay. Well, I got a streak, but it wasn't super, super thick, right? So let's see if we can cut glass with it. And try to do it on an edge, on an edge instead of a flat plane. And you might try a couple of different places. First time I tried it, it didn't do anything. And then second time I got just a little teeny scritch. It's not even that long of a scritch on the glass. So barely, okay? Whereas the streak plate, it gave me a streak. It wasn't huge, but gave me a streak. So it's probably pretty close to these in hardness, okay? So let's say, like 5 to 6, maybe 5 to 6, because we got a little teeny scritch on the glass, but not every edge did it, at least on my specimen. And we got a very thin streak. I mean, it was hard enough that the streak plate didn't get very much powder. Okay, so let's say 5 to 6, just somewhere in that ballpark. I already told you, no flat planes on this. This is fracture. And it's irregular fracture. This stuff does not have a curved surface. I mean, it might look like it does, but but even that curved surface has got irregularities. It's not smooth. So we're going to say irregular fracture. Well, when we see dark minerals like this, there is another item in our toolkit that we're going to want to use to see if it works. And that is the magnet. So this specimen is definitely tracks a magnet. Does it have enough of a pull that it'll actually keep the nail on it? Yes. So we put down here that in the special properties that it is magnetic. Okay, so let me put down all nice and neat and then bring the chart back up so you can see what I've got in there for this specimen. Oops. I don't know why I did that. 6 May, 5.5 to 6. All right, well, we get to use a chart of those 5 mineral ID charts that we haven't used before. We're going to take a look at the one for metallic and submetallic minerals. Okay, so what color was our streak? It was dark, right? Dark streak, green, black, dark brown, gray, black. Let's see, hardness of 1 to 2, that's not it. That's that graphite. Hardness of 2.5, gunmetal gray, cleavage 3 at right angles. Nah, too soft and got cleavage. Hardness 3.5 to 4, bright brassy yellow. That's not it. Hardness of 6, black. Streak is black to gray black. Density is 5.2. If you had a specimen that was in your drawer that was about the same size, this is kind of small, the one I've got. If it was about the same size, you could, balance one in one hand and one in the other, and this one, which should feel heavier. And then luster, submetallic, habit, equant, that doesn't matter. We're not looking for habit. Strongly magnetic, magnetite. That's what this mineral is. Okay. Let's go back out here and bring that up so you can see that last thing that I said here, magnetite. Only got 3 left. All right. This is H. Okay. All right, well, what color is that? It's not really gold, right? It's not lighted and shiny enough for being gold. So really, the color that this is what we would call brassy yellow. Does this sound familiar? Okay. Well, is it shiny? Yes, but I mean, it's not super shiny, right? This is not like a brand new coin or a brand new gold ring. So this is again submetallic. All right, streak. All right. Now, make sure when you have your specimen here, you may have some places on your specimen that look this brassy yellow and other places that look a dull gray. Make sure that you're doing your streak plate against the brassy yellow, because this kind of mineral often makes these thin sheets kind of mixed in with other stuff. Okay. So if you're going to do, like maybe if I did this flat surface here, I would do that because that's where that brassy yellow stuff is. Okay. All right. Well, so I went to an edge and I got a really nice, pretty good sized streak. And then if I were to look at it with my hand lens, and I don't have a lot of light here where I was sitting, but it's black, it looks black, which is not the color of the mineral itself, which is that brassy yellow. But if your eyesight's good enough, you might be able to see a little tiny bit of green, kind of very, very tiny green glittery in that black. Okay, so it might not be apparent to most of you, and it isn't with my specimen. I know what this is, right? Though, so sometimes you can see a little bit of green. I'm going to put black. because that's, to me, that's what it looks like. And hopefully the other characteristics are gonna help me narrow down what the mineral is. Okay, hardness. Well, I got the streak without too much of the problem is that if this is just flat little plates covering something else, so you got to make sure if you do it on the edge that you're doing it on an edge that has that brassy yellow. Yeah, I don't know. You know, one part of it, I put it against the glass plate, I don't get anything at all. You know, I put an edge against the glass plate and I got a scratch. Okay, not much of one. So, maybe not as hard as glass, but what's the next one down? The nail? Can you do damage to that brassy yellow surface with your nail? Can you scrape any off of it? Might want to scratch it right on top of your streak plate and see if anything comes off onto the streak plate or a white piece of paper. I get a little teeny bit when I do that with a 4.5 nail, all right? I don't think, you know, if you were to try the penny on it, I don't think it would do anything at all. In fact, if anything, it's going to scrape the penny, I believe. Okay, so let's put, let me check before I put you wrong. Yeah. All right, so it's harder than a penny, maybe not as hard as a 4.5 nail. So let's say 3.5 to 4. How's that? Oh boy. Well, this looks like it has some flat planes here, but if you actually feel the planes, they're not flat. Okay, so this is irregular fracture again. Okay, is it magnetic? Nope. When you look at your specimen up close, does it all look like that brassy yellow, or do you get, you know, when you move it around in the light, do you get a little stuff that almost looks like a little bit of a rose colored, like a pinky look to it? Or any kind of blue or purple? That's where the mineral has perhaps gotten some weathering done to it. So you might get some, I call it like rainbow in color, maybe. Rainbow, I don't know how to spell rain. Map text. Oh, please, I need to put them in. Okay, so let me show you my chart now. So brassy yellow, it's got submetallic luster, and so we're going to use chart A again, true? All right, it's 3.5 to 4. It had a dark streak, so it's going to be up in this upper part. Let's see, it's not graphite, 1 to 2. Here's 2.5. This is got middle grade. This is the one that had the cleavage 3 at right angles. Then we got one that's 3.5 to 4, bright brass yellow where fresh, tarnishes to iridescent purple peacock ore. Streak is green black, and it's brittle. Now remember how I said it's like in these plates that are kind of molded over other stuff? That's what it means by brittle. You can flake it off. And it's chalcopyrite, which is actually a major ore where we extract copper out of it. Okay. So over here on my chart, right? Back to that chart again, so you can see how I spelled it, right? Chalcopyrite. All right, we're only down to 2 now. Oh, my specimen's probably even worse than the other one that was like this. This is I. Okay. Right off the bat, you said, wow, that really looks like biotite. It's just not brown. Okay. So when we look at the color, this particular specimen is so thin, it does have a little color to it. It's not, it's not totally transparent. Okay. But maybe slightly, I don't know, clear beige. Luster. Pretty bright, but is it as sharp as glassy? This is what I would call pearly luster for sure, which is a type of non-metallic, right? Streak. Oh, how are you going to get a streak off that? But think about it. What color is this? So if it did powder, it would probably be white. So we're going to be just think logically about it. Hardness. We can't get a streak because it's just, I mean, I've got a little bit of an edge here, but it's just these things are so flexible. They don't really, they bend before they break almost. Okay. So I'm going to get down into the nitty gritty. Does my fingernail do damage? My thumbnail? Well, it puts a dent in it and I just get a little teeny bit of white underneath the edge of my nail. How about the penny should be able to do something then, huh? Oh yeah, the penny's relatively easily doing something to it. So let's put 2, 2.5. I just blew part of my specimen away and I don't know where it went. Okay. Well, do you remember what the cleavage is for these guys? Remember biotite, what it had? When you could only put one finger and thumb, you can't move it around to another part. Okay. Transparent in thin sheets and, flexible. I could bend these. Transparent. Thin. Wait, flexible sheets. Right. So let me go out of this, go over to the actual chart. Clear beige, you can put clear, pearly, luster, white streak, 2 to 2.5, 1 perfect, transparent, flexible sheets. What do we call this? Go over to our mineral ID charts. Let's see, that's metallic. So we now need to go cleavage softer than glass. Hardness of 2. It's not gypsum, not sylvite, not chlorite, because that's medium to dark green, not halite. We've already done that. Hardness 2 to 2.5. Cleavage 1 perfectly planar. Colorless to white to light greenish brown. Streak white. May break apart when testing. Resinous to vitreous to pearly luster. Sheets elastic, flexible, and transparent. This is muscovite. Okay. Okay, so there we have our muscovite. And our last specimen is another dark one. And I got a pretty good size chunk in my kit. I don't know how big yours are, but I think I put this one in here because it shows cleavage well. All right, so notice that it looks black, but it has, and you might have some in your specimen too, it has these little teeny white to clear. Well, when this is cooling, this is something that comes in igneous rocks. And when the magma or the lava is cooling, and it's for this big of a chunk, it would be cooling underground, so it'd be magma. There's another type of mineral that cools at the same temperature range. So as the magma's cooling, depending on what its composition is, there's going to be a lot of it's going to be making like big minerals like this, but then it also might be making small minerals of a different type of mineral. And then they just get combined together in a big specimen like this. But you won't always see those accessory minerals in these, but often you do. Okay. So the color of the majority of it though is black. Does it have luster? Well, no surface on here is going to be perfectly planar. But if you, and don't think about necessarily the white ones that are really blinking at you, but, ooh, here we go. See how that face right there? It's blinking. And then this face here does the same thing. It's not as strong as you might get on a light colored specimen. Here, that face does a really good job of it. But it's not perfectly flat. There's a lot of stair stepping. This mineral has a tendency to look kind of fibrous. Okay. Whereas these faces, the little white minerals in it might be shining at you, but you don't get that blink of total light like you do on the large faces here, okay? So the ones that have the blink of light are cleavage plates. The ones that don't are not. So this is gonna have two cleavage, and now we just have to figure out what angle it is. So here's one of the cleavage planes, right? And then around the other side is another. So that angle, okay, here, that's one angle. That is larger than 90. And the other angle is this angle. Wait, that's the same one. So this one and this one, this is larger than 90. And this one is smaller than 90. It's supposed to be 60, 120, but the way this one has that fibrous quality that allows it to do all those little tiny stair steps, sometimes it's hard to see the actual cleavage. So what do we got here? It is glassy luster, even though it doesn't blink real sharp at you. And then I did the cleavage, so we got two at not at 90. Okay, well, what about the streak? So again, make sure there's nothing else on your streak plate. And it like broke little pieces off. Some of it's powder, but some of it's little chunks. And the little chunks is because of, like I said, it's kind of a fibrous texture. I mean, fibrous and it looks fibrous. It's not soft like fibers, obviously. But the color of the streak is black. Hardness. It wasn't too difficult to get stuff to break off, but some of it was chunks, not powder. So let's see if it'll cut glass. You know, and you're gonna want to do it along a edge. Yes. I got the streak, and I don't know if you can see it the way this is. Well, anyway, I got a cut in the glass. Not a really deep cut though. Okay. So it's going to be right in that inside between and among the glass plate and the streak plate. So maybe 5.5 to 6 for hardness. Special properties, if any. Ever since I did geology, my first years of geology way back in the late 80s, every time I've taken a class that has minerals in it or taught a class that had minerals in it, these minerals, this particular mineral typically has this, it almost looks like charcoal, you know, that fibrousness to the cleavage planes. It almost looks like a not a charcoal briquette that's made for you to put into your barbecue. Those are manufactured, but like a piece of burnt wood kind of a thing. Okay, that's what it reminds me of. And for whatever reason, the person who did the mineral charts didn't put that as a quality when she was building all the things about it. So, all right, so first I'm going to show you the chart. Black, glassy luster, black streak, 5.5 to 6, 2 not at 90 degrees for our cleavage. No, not really anything, you know, you could put texture that looks like real charcoal. Wrap text. Okay, so let's go find that in our chart set. Share screen, here's our charts. We want the chart that is harder than glass and with cleavage, right? So here's cleavage and parting and harder than glass. About as hard as glass. Okay, let's start there. 5 to 5.5, cleavage 2 at 84. Well, that's kind of close to 90. Splintery to hackly. Fracture. Wait, the surfaces are splintery to hackly. White, colorless to gray. Well, that doesn't work. Hardness of 5, parallel to blades, and then a hardness of 7, perpendicular to blades. Blades? Cleavage 2 directions at 74, blue to gray to green, that doesn't work. Hardness 5 to 6, cleavage 2, 120 and 60, medium to dark green, that doesn't work. Hardness 5 to 6, cleavage 2 at approximately 120 and 60, greenish dark gray to black, streak pale gray, if any, which means that it, you know, that it might give you chunks and not powder if you were to put it against the streak plate. Luster is vitreous with glassy. Habit is prismatic with a diamond-shaped cross-section. And then the one up here, these are 2 at 90, so it can't be that because they're definitely not at 90. So has to be hornblende for the color to work. Okay, all three of those, the actinolite and hornblende are both amphiboles. You know, they're in the same general mineral group. Okay. Let's go back over to the chart and I'll show you that back again. All right, so here's the chart. So if you filled it out like I did with your typing, then you need to save it. And again, if you use Excel, you can just upload it in Excel. But if you use a different chart programs, like something on Google Docs or something like that, then you need to save it to a PDF file, and then upload the PDF file. Because something else, if you're saving it besides in Excel or PDF, I'm not going to be able to open it. And if I can't open it, then I can't know that you actually did the chart the way you were supposed to, even if you just went along with this video and copied me. Okay? So you have to be able to upload it. All right. So stop share. So as I said, all the information on that chart, the way you filled it out, if you filled it out with me, it should tell you everything you need to be able to answer the questions on the question worksheet, which is this document. Okay. So like, let's say specimen A. Yeah, I just asked you, what is it? Okay. Now we came up with the fact that it was an alkali feldspar. Okay. Then when you would just answer feldspar. Specimen B, what's its luster? We said it was glassy. Okay. It has a glassy luster. Specimen B has a hardness of, we said that it was greater than 6.5, but we also said that it is quartz, which has a hardness of 7. So you're going to want to say 7. Question 4, specimen B has, well, conchoidal fracture, right? That's what we came up with. And then it asks you, what is specimen B? There's a lot of questions for specimen B. Question 6, specimen C. What kind of cleavage does it have? Okay, well, if your specimens meet at, and I should have said something about this in the textbook. If your specimens meet at 60-120, that's rhombohedral cleavage. Does it? Is it one perfect? Then that's basal cleavage. Do your specimens meet at 3 at 90? Then it's probably cubic cleavage. Okay, so which one does specimen C have? It's definitely not fracture. What's specimen C? Give me the name. Question D, or question 8 for D, specimen D. The hardness of is what? Specimen D has what kind of cleavage? Special property of specimen D is that it, okay, and so on. And then, like I said, when you get to, I'm not going to do a separate video, I'm just going to go with this one. When you get to these, you just need to refer back to the mineral charts that are included in the folder, these, and just take those qualities that I've given you, and you can see the color probably from just specimen, and find which, find the chart and then find the actual specimen name. Okay. Okay, hope that helps. And I know it's kind of lengthy, but maybe you can fast forward into places where you feel pretty confident. You could, check the chart later. I'd kind of like you to get an idea about what it really is to test all of the different minerals, but I can't, I don't have any control over what your timing is like. So I'll get this up as soon as I can. Let's see, recording. Stop recording.